Welcome to Health Management Information Systems. What is health informatics? This is Lecture A. This lecture will define information management, information technology, and informatics. Describe the fundamental theorem of informatics, explain the meaning of biomedical and health informatics as a field of study, and offer definitions of the major biomedical informatics areas of applications. It will also provide an overview of informatics drivers and trends in the healthcare field. The objectives for this lecture are to define information management, information system, technology, and informatics. Explain the basic theoretical concept that underlies informatics practice. Define the meaning of biomedical and health informatics as a field of study. Describe the biomedical informatics areas of applications and summarize the informatics drivers and trends. This introductory lecture will define information management, information system, technology, and informatics. Describe the fundamental theorem of informatics, explain the meaning of biomedical and health informatics as a field of study, offer definitions of the major biomedical informatics areas of applications, and provide an overview of informatics drivers and trends. Let's begin with defining information management, information system, technology, and informatics. According to the American Health Information Management Association, AHIMA, information management is the generation, collection, organization, validation, analysis, storage, and integration of data, as well as the dissemination, communication, presentation, utilization, transmission, and safeguarding of the information. If the type of information were health, then health information management would entail acquisition, organization, storage, retrieval, and dissemination of health information from a multitude of places. The purpose is ensuring availability, accuracy, and protection of health information that is needed by a variety of individuals in the delivery of healthcare services and to support decision-making activities. An example of information management would be deploying a content or document management system. The next definition in the series of terms closely related to information management and informatics is information system or technology. AHIMA defines information system as an automated system that uses computer hardware and software to record, manipulate, store, recover, and disseminate data. That is, a system that receives and processes input and provides output, often used interchangeably with information technology, IT. When you think of information technology, some things that should come to mind are computer networks, database and systems administration, security, and programming. Therefore, information technology could be used in the management of information. Connecting information technology to health, consider the following definition by the Office of the National Coordinator for Health Information. Health Information Technology, HIT. The application of information processing involving both computer hardware and software that deals with the storage, retrieval, sharing, and use of healthcare information, data, and knowledge for communication and decision-making. An example of health information technology would be administrative and financial systems that facilitate billing, accounting, and other administrative tasks. The final definition in this information series comes from authors Elmer Bernstam, Jack Smith, and Todd Johnson in their article, What is Biomedical Informatics? Based on their research, they determined data, information, and knowledge were central to informatics. Their literature review and subsequent analysis concluded in the following definition of informatics: informatics is the science of information, where information is defined as data with meaning. Thus, the similarity between all three terms is that all involve information in some way. However, a critical difference between information management, information technology, and informatics is in the object of study, where information management focuses on the organization and dissemination of information, information technology on the tools and machines, and informatics on the optimal use of meaningful data. In order to gain a better understanding of informatics, one needs to learn the differences between data, information, knowledge, and wisdom. As explained on the previous slide, the research performed by Bernstam, Smith, and Johnson, 2009, showed that data, information, and knowledge were central to informatics. In their article, they referenced Ackoff's data, information, knowledge, and wisdom, DIKW hierarchy. Jennifer Rowley explored further the DIKW hierarchy. Rowley states the hierarchy is used to contextualize data, information, knowledge, and sometimes wisdom with respect to another and to identify and describe the processes involved in the transformation of an entity at a lower level in the hierarchy to an entity at a higher level in the hierarchy, for example, information. The explicit assumption is that data can be used to create information. Information can be used to create knowledge, and knowledge can be used to create wisdom. Data are simple symbols, isolated facts, and measurements. When such data are processed, put into a context, and combined within a structure, information emerges. Information provides the answers to who, what, when, and where. When information is given meaning by interpreting it, that is, there is an application of data, information becomes knowledge. Knowledge answers the how questions. Finally, wisdom is evaluated understanding and answers the why questions. Central to informatics is the processing of data so it becomes meaningful. Building on what has been learned so far, Dr. Friedman's proposed fundamental theorem of informatics will be reviewed next. Other theories, such as Bayes' theorem, also apply to informatics but will not be addressed in this unit. Merriam-Webster's online dictionary defines a theorem as an idea accepted or proposed as a demonstrable truth, often as a part of a general theory. Dr. Friedman utilized figure 1.1 to represent the theorem. The picture is that of parentheses, picture of a head of a person, a plus sign, picture of a computer, parentheses, greater than symbol, picture of a head of a person. According to Dr. Friedman, this figure is to be interpreted to mean a person working in partnership with an information resource is better than that same person unassisted. He further explains the metaphoric person depicted in the theorem can be a clinician, a scientist, a student, a patient, or an administrator. The person can also be a team or group, or even an organization. The information resource is any mechanism capable of providing information or knowledge or advice to support the person's completion of a task. Information resources are usually, but do not have to be, computer-based. The plus in the figure is intended to convey interaction between the person and the resource, the outcome of which is determined by what the information resource is capable of, as well as how the person elects to use it. The plus symbol is employed because of its universal recognition, but is not to be read literally in the sense of mathematical addition. The parentheses further connote a bonding between the person and resource, and suggest that the person-resource interaction is shaped by its environment or organizational context. Better and the greater than inequality are used loosely by intention, so as not to convey specific requirements for testing the theorem. Now that you have a better understanding of informatics, let's look at where one would find this science applied. As one would expect, there is not just one segment or domain for informatics. Any domain where there is a need for analysis of data and dissemination of information through the use of computer applications is a possible application domain. These include a wide range of industries, including entertainment, hotel management, law and law enforcement, healthcare, and many other fields where computer technology interfaces with people. As the focus of this unit is what is health informatics, informatics and its application to healthcare will be explored further. While various perspectives of informatics and its application to healthcare have been published, two have been chosen for review and discussion because of their significance within the field. The first definition comes from the American Medical Informatics Association, or AMIA. AMIA is a nonprofit organization dedicated to the development and application of medical informatics in the support of patient care, teaching, research, and health administration. This organization is seen as the prominent informatics organization in the U.S. According to their website, EMEA is the professional home of leading informaticians, clinicians, scientists, researchers, educators, students, and other informatics professionals who rely on data to connect people, information, and technology. EMEA's definition, therefore, is essential to understand. Accordingly, biomedical informatics, BMI, is the interdisciplinary field that studies and pursues the effective uses of biomedical data, information, for scientific inquiry, problem solving, and decision making, motivated by efforts to improve human health. The second definition comes from another highly respected source for biomedical informatics material, the textbook Biomedical Informatics, Computer Applications in Healthcare and Biomedicine. Shortliff and Blois define biomedical informatics as the scientific field that deals with biomedical information, data, and knowledge, their storage, retrieval, and optimal use for problem solving and decision making. As a field of study, Shortliff and Blois state biomedical informatics is concerned with the broad range of issues in the management and use of biomedical information, including biomedical computing and the study and nature of biomedical information itself. Another term you may come across is health informatics. It has various interpretations, but each one connects information science to healthcare in some fashion. For example, EMEA's perspective is the informatics community typically uses the term health informatics to refer to applied research and practice of informatics across the clinical and public health domain, while AHIMA defines healthcare informatics as the field of information science concerned with the management of all aspects of health data and information through the application of computers and computer technologies. As you can imagine, applying information science to healthcare requires health informatics standards to define acceptable methods for collecting, organizing, maintaining, and exchanging data among health management information systems. Shortliff and Blois, 2001, view biomedical informatics as 4 subfields, which is represented by Figure 1.2 shown on the slide. Public health informatics, clinical informatics, imaging informatics, and bioinformatics, each with a specific focus, as represented by the left-hand side. The right-hand side lists the component sciences in biomedical informatics, which includes computer science, clinical science, basic biomedical science, cognitive science, bioengineering, management science, and epidemiology and statistics. The next few slides explain Figure 1.2 further. To begin, Shortliff and Blois define biomedical informatics as the scientific field that deals with biomedical information, data, and knowledge, their storage, retrieval, and optimal use for problem solving and decision making. As a field of study, Shortliff and Blois state that biomedical informatics is concerned with the broad range of issues in the management and use of biomedical information, including biomedical computing and the study and nature of biomedical information itself. Biomedical informatics encompasses public health, clinical, and imaging informatics, as well as the biological and biomolecular informatics domains. These 4 subfields, public health informatics, clinical informatics, imaging informatics, and bioinformatics, are where the informatics applications are geared toward a specific area, such as the individual in the case of clinical informatics. The University of Medicine and Dentistry of New Jersey and the New Jersey Institute of Technology published some examples of a biomedical informatics application, including reducing diagnostic uncertainties and improving clinical decision-making by using computing techniques and information technologies, utilizing computational approaches and modern computer-based techniques in drug design, molecular genetics, and cellular genetics to solve complex clinical problems, designing and managing clinical, pharmacy, radiology, laboratory, or hospital information systems. The next 4 slides provide additional information for each subfield. The first informatics segment is public health informatics. Shortliff and Blois define public health informatics as an application area of biomedical informatics in which the field's methods and techniques are applied to problems drawn from the domain of public health. Public health informatics is population and society focused. Examples of public health informatics applications include the National Notifiable Disease Surveillance System, the National Electronic Telecommunications System for Surveillance, NETSS, immunization registries, immunization information systems, homeland security, bioterrorism. The second informatics segment is clinical informatics. As defined by Shortliff and Blois, clinical informatics is the application of biomedical informatics in the patient care domain, a combination of computer science, information science, and clinical science, designed to assist in the management and processing of clinical data, information, and knowledge to support clinical practice. Clinical informatics is individual, patient-oriented, focused. An example of clinical informatics applications would be the electronic medical record. The third informatics segment is imaging informatics. Imaging informatics is concerned with the common issues that arise in all image modalities, relating to the acquisition of images in, or conversion to, digital form, and the analysis, manipulation, and use of those images once they are in digital form. Imaging informatics is tissues and organs focused. An example of imaging informatics applications is a computerized tomography (CT) scanner, which uses software algorithms to recreate a three-dimensional image of the body parts. Another example is picture archiving and communication systems (PACS), which are a combination of hardware and software dedicated to the short and long-term storage, retrieval, management, distribution, and presentation of images. The final informatics segment is bioinformatics, or the study of how information is represented and transmitted in biological systems, starting at the molecular level. Altman and Mooney, 2001, page 763. Bioinformatics is molecular and cellular processes focused. An example of bioinformatics applications is genomic sequencing. Having covered the subdisciplines of biomedical informatics, Shortliff and Blois addresses the component sciences that biomedical informatics draws on and contributes to. These include computer science, clinical science, basic biomedical science, cognitive science, bioengineering, management science, and epidemiology and statistics. Let's now explore what is a driving force in healthcare that is fueling the need for informatics applications. The American Recovery and Reinvestment Act, or ARRA, is officially Public Law 111-5, signed into law February 2009. The Health Information Technology for Economic and Clinical Health, often referred to as HITC, is a provision of the American Recovery and Reinvestment Act. The HITC section of ARRA deals with many of the health information communication and technology provisions. ARRA, and specifically HITC, was a major driver of health informatics through its many different stimulus opportunities, one of which is $19.2 billion for health information technology. The Office of the National Coordinator for Health Information Technology defines health information technology, HIT, as the application of information processing involving both computer hardware and software that deals with the storage, retrieval, sharing, and use of healthcare information, data, and knowledge for communication and decision-making. The funding assisted providers and states in adopting and utilizing health IT in order to achieve widespread adoption of health IT and enable electronic exchange of health information. The stimulus funding has since slowed, but penalties for not using electronic health records meaningfully are in place and the drivers are still there. In addition, the Patient Protection and Affordable Care Act, sometimes called Obamacare, is emerging as a significant driver for change in healthcare. These changes, many of which focus on changing how healthcare organizations are funded or reimbursed, require robust use of health IT for collecting, measuring, and reporting on care. The ACA will likely be the most significant driver for health IT changes in the future. Why else are informatics applications a growing need? Trends which are stimulating the need for health informatics applications include the focus on e-health, the adoption and implementation of electronic medical records, or EMRs, and electronic health records, or EHRs, and the growing desire to be able to electronically exchange health information across organizations within a region, community, or hospital system. The application of information technology to healthcare is a critical tool in achieving the benefits of e-health, EMRs, EHRs, and health information exchange. As you will learn later in this unit, practitioners of informatics, known as informaticians, use information technology to advance cost-effective care, high-quality care, and patient safety. But first, let's review the connection informatics has to e-health, electronic medical records, electronic health records, and health information exchange. A general direction with regards to health IT relates to the global environment. The World Health Organization, or WHO, a United Nations agency responsible for directing and coordinating international health activities, recognized a trend involving the use of information and communication technologies and its impact on healthcare delivery, public health, research, and health-related activities. With this recognition, WHO set about defining e-health and developing a WHO e-health strategy to help direct WHO's activities on e-health. As defined by the WHO, e-health is the use of information and communication technologies, ICT, for health to, for example, treat patients, pursue research, educate students, track diseases, and monitor public health. The HIMSS definition is the application of Internet and other related technologies in the healthcare industry to improve the access, efficiency, effectiveness, and quality of clinical and business processes utilized by healthcare organizations, practitioners, patients, and consumers to improve the health status of patients. Thus, there is a very close connection between e-health and informatics, as it is the combined use of electronic communication and information technology in the health segment. Some in the industry see e-health as a subdiscipline of health informatics. Certainly, the application of information and communication technology to healthcare is a critical tool in achieving the benefits of e-health, such as improving healthcare delivery. An example of e-health is telemedicine, which is delivery of healthcare at a distance, most often via the Internet. Another trend of health IT, which is impacting the field of health informatics, is the adoption of electronic medical records, or EMRs, and electronic health records, or EHRs. These applications could be thought of as centerpieces of health informatics. The report, defining key health information technology terms, defines an EMR as an electronic record of health-related information on an individual that can be created, gathered, managed, and consulted by authorized clinicians and staff within one healthcare organization. An electronic medical record is a record of medical care created, managed, and maintained by one healthcare organization. EMRs, being an electronic equivalent of an individual's legal medical record for use by providers and staff within one healthcare organization, are part of the health information technology infrastructure and have a direct tie to health informatics. A related trend driving the health IT market and the direction the healthcare industry is going is the implementation of electronic health records. As with electronic medical records, EHRs could be considered to be the center of health informatics. In the report, defining key health information technology terms is this definition: an electronic record of health-related information on an individual that conforms to nationally recognized interoperability standards and that can be created, managed, and consulted by authorized clinicians and staff across more than one healthcare organization. Key components of electronic health records include administrative system components, laboratory system components, radiology system components, pharmacy system components, computerized provider order entry, and clinical documentation. Being a repository of individual health records that reside in numerous information systems and locations, EHRs are intended to support efficient, high quality integrated healthcare, independent of the place and time of healthcare delivery. Consequently, EHRs too are a part of health information technology infrastructure and therefore linked to health informatics. The final trend is the utilization of health IT in order to achieve widespread adoption of health IT and enable electronic exchange of health information. Included in the report, defining key health information technology terms, is the following definition for Health Information Exchange, HIE: the electronic movement of health-related information among organizations according to nationally recognized standards. HIE involves networks that give providers the ability to electronically transmit in a secure manner an individual's health records. Through the utilization of EHRs, HIE supports the sharing of health-related information to facilitate coordinated care. EHRs draw information from many sources through Health Information Exchange. Thus, the process of health information exchange is another piece of the health information technology infrastructure and informatics. There are many local, state, and national HIE initiatives going on throughout the U.S. This concludes Lecture A of What is Health Informatics. Lecture A defined information management, information technology, and informatics, described the fundamental theorem of informatics, explained the meaning of biomedical and health informatics as a field of study, and offered definitions of the major biomedical informatics areas of applications. It also provided an overview of informatics drivers and trends in the healthcare field.